Okay, in this problem it says we've got a graph of f prime, the derivative of f, and it's the line shown in the figure. F of 0 is 5. We need to find f of 1. So I'm going to use this as a way to kind of give you a couple of concepts that you might think about and just latch on. I mean, try to understand both, but latch on to one that you think is reliable. One way to do this is that to recall that by the fundamental theorem of calculus, an integral from a to b of a function can be evaluated by where the function capital F is any antiderivative of what's inside, right? Lowercase f, the f with the tail. We can use that here. Don't be thrown by so we're given the graph of f prime. That must mean that f, right? If f prime is the derivative of f, then that just means that f is an antiderivative. F is an antiderivative of f prime. That's like definitional, right? Like f is an antiderivative of f prime because f prime is how we notate the derivative of f. So of course that's true. So how is that useful here? Well, just try to write down a statement from our graph. We have the values are 0 and 1. So if we use this approach, right, the integral from 0 to 1 under my graph f prime, according to the fundamental theorem, should equal, so our antiderivative is just f evaluated at 1 minus f evaluated at 0. We can find f of 0 because they told us it's 5. And we can find this because it's the area of that triangle above. So the area of this triangle above is 1/2 1 times 6. So that's 3. So I'll just put that in there. So now I've got that 3 equals, we're trying to find f of 1 minus 5. Adding 5 to both sides, we get. Okay. So that's a legitimate way to do it. That's D. The other way you could think about it instead, if it helps, is like a function's value at 1. Okay, a function's value at 1 is going to be whatever a function's value is to start, meaning like, and the start just any value they gave you. Okay, its value is start plus change. How does a function's value change? Well, if we accumulate area from 0 to 1 under f prime, that will accumulate the change in f. Okay, again, this is like, position. Your position at any time is starting position plus the integral of velocity, where velocity is a derivative of position. F prime is a derivative of f. So it's the same idea, just more generic. Again, we want this, so we don't expect to fill that in. F of 0 was 5, and then again, the area we learned there was 3, so we get 8 either way. So those are two representations of the fundamental theorem here and here, but notice they both lead to the right answer.